All right, guys, I hope you're ready to learn some math today. We are doing something super exciting. We are going to be deriving rules so that we don't have to use limits to do derivatives anymore. Using limits to do derivatives takes a while. It's a little bit clunky. It's a lot of work, and it's important. We want to be able to find the slope of a curved line, but we will be able, at the end of today, to be able to use rules to do things instantly. I don't know if you've looked at your homework yet, but if you were to try to do your homework using the methods we've been using, it would take you like 20 hours to do. And so we're going to spend some work today. It's going to be a bit of a lesson. It's going to be some work. But the work we're going to put in is going to take your homework from taking 20 hours to taking like an hour, right? So it's very much worth it. So we're going to start out by making sure we all are on the same page with some skills. And the first thing we're going to look at is making sure we understand fractional and negative exponents. So I want you to rewrite this as, each one of these is going to be rewritten as x to the a. So you're just rewriting it as x to some power, and you're figuring out what a is. So this is x to what power? And I hope we remember that fraction exponents give us roots. This is x to the 1/2 power. Remember that if there's a fraction power, it's actually a root, and whatever's in the denominator is this part. We don't actually need to write the 2 here because a root with no number automatically means a square. This means a square root. It's the second root. And then this would be x to the 1 power, but we don't actually have to write the 1 because x to the 1 power is 1. So this is what this root, this is what this power means. This is x to the 1/2 power, which is the square root of x. Okay, so hopefully we remember square root powers from before calculus. Let's look at the next one. How do we rewrite this as x to some power? And hopefully we remember that negative exponents tell us to divide. So this is x to the -2 power means 1 over x getting, so the negative means 1 over x squared. And so the power that we needed here was x to the -2 power. Okay, another one to try. What exponent needs to go on x here? So x to what power? We'll make it be the cube root of x squared. And this is, of course, another one of those fraction exponents. The cube root is what goes in the denominator. So that's the denominator because it's a cube root. And it's getting squared, so it's x to the 2/3 power. So remember that whenever we want a fraction power, we know we need it to be this 2/3 power means the denominator is going to be the root, and this is what x is happening. You can also put it as this squared can be here or on the outside. It actually comes out to be the same thing. It's fine. Okay, this next one. How do we rewrite this as x to some power? What power do we need here? And because it's dividing, we should notice that that is negative. It's a negative power, and it's just x to the -1 power because it's 1 over x to the 1 power, and x to the 1 power is x. Okay, last one. How do we rewrite this as x to a power? And we rewrite this as, well, I see it's negative. It's going to be a negative power because it's 1 over. The negative will make it be 1 over. And I see it's going to have a fraction in it because it's a root. There's no number here, so it must be a square root. So that goes in the denominator, and x is not being taken to any power, and so it's to the 1/2 power, x to the -1/2 power. This negative part means it's 1 over, and then x to the 1/2 power means it's a root because it's a fraction, and this is the square root of x to the 1 power, and the square root is just, we just write it like this, and x to the 1 power is just x. So these are the same. Okay. All right, guys, hopefully we feel good about that. We are going to do this because one of the rules we're going to be coming up with today is called the power rule, where if you have x to any power, you will be able to take the derivative of that instantly by the end of today. It's super powerful. But what x to a power means is that, like, because we can do it with x to any power, things that look like this are also just x to any power, in addition to something like this. This is x to a power, but so are all these. And so if you're able to rewrite all the things you're supposed to as x to a power, you'll be able to take the derivative of a lot of things instantly.